Now I am.
It says a trough is 15 feet long, 4 feet across the top, as shown in the figure. Its ends are isosceles triangles with a height of 3 feet. Water runs into the trough at a rate of 2.5 feet cubed per minute. How fast is the water level rising when it is 2 feet deep? Okay, so here's the thing with this one. It's a volume, right? Because it talks about it being 2.5 feet cubed per minute is how fast the water is running into the trough, so they're filling it up. So that is a dV dt is 2.5 feet cubed per minute, right? So since it, when it gives you that feet cubed, it's a volume per minute, lets you know it's a rate. And so it's increasing, it's filling up the tank at 2.5 feet cubed per minute. So they gave us a dV dt. Now also in number 12, they say that it is a triangular trough, right? And so it has isosceles triangles on the end. So we need to know the volume of this thing. And so remember, anytime we talk about the volume of a prism, and so it's got two triangles on the end, right, and then all these rectangles running across, and so it's kind of making that trough. And so remember, we said anytime you have a shape on either end and then rectangles connecting them, the volume is always what?
Surface area times.
Not surface area, but just
area.
So I'm going to put A times H,
Wait,
right?
Area of what?
Area of whatever the shape on the end is. In this case, the shapes on the end are the triangles, right? Okay, so, but there's one little trick to this. Okay, so let me go ahead and draw a very bad picture of what they have. There's a triangle here, and there's a triangle here. And then you kind of have the trough being connected. Okay? Did I crisscross it? Either way. Okay, it's a triangular trough here. So here, and then let me draw with a little tilt. See if I can make this a little bit better.
Do one triangle a little bit higher.
So we're trying to connect these.
Yeah.
Right? Yeah, they're in the black bag right there. Okay? Now the only thing is, when we talk about this triangle, they said that it was how tall?
3.
Yeah, it's 3 feet tall. Okay? And then how wide is it across the top?
4 feet.
That's 4. And then this distance right here is how much? 15. Okay? So in this right here, when I say volume is area times height, then it would be the area of this triangle on the edge times the what? 15. Yeah, so this right here would be our height, but we need to rename it because what we're going to do, remember the area of a triangle is 1/2 base times height.
So this
The
is
height
like,
that this is talking about in the area of the triangle is talking about this one right here, which is the 3. The base is this base part of the triangle right here, it's the 4. So what do y'all want to call this right here, this 15? Okay, you want to call it length? Okay, so we'll use an L right there instead of the H to represent that length of 15. So here's the volume of this thing.
42.5. Or whatever you asked me to.
Well, we don't need it right now. We don't need the actual volume. We got a dV dt because we got to take the derivative of this thing. And so if you look at the end, it says, how fast is the water level rising when it is 2 feet deep? So what is that actually giving us? A water level means a what?
height.
Height.